Good morning, everybody. So we are going to start the new unit today. So in this new unit, we're going to be talking about trigonometry, and we're going to spend some time here in lesson one reviewing some things that you should remember from geometry. So first things first, the opening exercise. Right, so I'm asking you to pause the video for a second, take a look at these two triangles and see if you can compute the two ratios that I'm asking you about there, and see if you notice anything. Okay, so hopefully you paused the video and you actually tried this yourself. I'm going to say that multiple times throughout this video. So we have compute the ratio of segment CB. CB is the ratio of the side length of 1. And AC, which is the side length of 2. The ratio of FE to FD, well, FE has a length of 2. And FD has a length of 4. I picked these two sides for a reason, because I'm hoping that you notice that even though these are different sized triangles, these ratios are equal to each other. That is something you learned in geometry. These triangles are what are called similar triangles. We would have said triangle ABC is similar to triangle DEF. And I know some of us are getting geometry PTSD right now. It's okay. We're not going to do similar triangle proofs and all that crazy stuff like we did last year. We're just going to use the idea that triangles that are similar, meaning they have the same angles, are going to have ratios that are in the same proportion, or the same sides that are in the same proportion or ratio. That concept is the whole basis of where trigonometry actually comes from. So if we take a look here, there were some ratios that we learned about in geometry. In geometry, we said that there's a symbol that we use usually for unknown angle. It's called theta. That's what this little symbol means here. So theta is basically our variable for an unknown angle. Right? It's like a placeholder for the angle that we don't actually know the value of. So if we have a right triangle, inside of that right triangle, we're going to have some sides. Those sides have special names. And those sides are all in a relationship to where theta is labeled. So for example, if I have this triangle, and I put theta here, and this is my right angle, since theta is touching this bottom leg, this is what we call the adjacent side. Since theta is looking at this opposite side, we call this opposite. And the longest side, the side opposite of the right angle, we call the hypotenuse. Well, if I redraw the same triangle, but I put theta here, the hypotenuse isn't going to change, but the adjacent side and the opposite side kind of flip-flop. So what you learned last year with SOHCAHTOA, or sine, cosine, and tangent ratios, was how to manipulate and use them to find missing angles and missing sides. That's geometry. In Algebra 2, we're going to use these ratios to create functions, so that we have these input numbers and these output numbers, and we're using the fact that these ratios happen in all these different types of triangles to kind of move around and talk about angles that are even bigger than 90 degrees. So let's today just practice the idea of sine, cosine, and tangent ratios. Again, this should be a review of geometry. So number one says, consider right triangle ABC, where angle A is 30. So I'm going to put 30 here. This is my theta. This is my angle. So if that's my angle, the opposite side would be 1. The adjacent side should be the square root of 3. And the longest side, the side opposite the right angle, should be the hypotenuse. So what we have to be able to do here to find the sine of 30, cosine of 30, etc.
I just want to ask
I don't know.
Oh, okay.
Okay, so if we go through here and we do the sine of 30, well, if I'm talking about 30, that's the opposite side is 1, because sine represents So that's how we can show that. Cosine represents ka, and tangent represents toa. That's a quick way of remembering it. So if we're talking about sine, this is the opposite side over the hypotenuse side. So that ratio is 1/2. For cosine, the ratio is going to be the adjacent side over the hypotenuse. So the square root of 3 over 2. And for tangent, we're going to have the opposite side over the adjacent side. So 1 over the square root of 3. Now, I do this every year because I don't think we, as math teachers, sometimes do a good job in geometry of kind of explaining where these numbers come from in our calculator. I think we get caught up. I know I used to do it too when I taught geometry. I got caught up in like, let's just use the calculator to find the sides. So, like, if I plug some stuff into my calculator, I'm going to notice something really quickly, right? So let me grab my Desmos calculator here. So when you are doing anything in trigonometry here and we want to type stuff in, we have to know whether or not we want to be in degrees or radians. Right now, everything we're going to do is going to be in degrees, which it's already highlighted right on our little gearbox, right? So if I type in the sine of 30, so if I go to functions, I hit sine, and I type in 30, it gives us 1/2. That's the ratio I just got in my triangle. If I type in the cosine of 30, I get this weird decimal, which guess what? That weird decimal is going to be the square root of 3. I don't want to be there. I want to be over here. There we go. The square root of 3, and that's going to be divided by 2. Notice it's the same decimal. So these numbers that we're getting in our calculator when we were in geometry refer back to these 3 numbers from this right triangle if the angle we're talking about is 30. Let's do the next one. So for the next one, I'm asking about 60. Well, we already were told that A was 30, meaning C would have to be 60 because we know that triangles, angles have to add up to 180. So if we relabel this, this is the adjacent, this is the opposite, and this is the hypotenuse. So if I'm talking about sine, again, that's so, ka, toa. Right, so if we're talking about sine, it's the opposite side over the hypotenuse side. The cosine is the adjacent side over the hypotenuse side. And the tangent is going to be the opposite side over the adjacent side. A couple of things I'm hoping you notice right away after seeing the answers to 1 and 2 is they're the same ratios just in different places. Like the sine of 30 became the cosine of 60. The cosine of 30 became the sine of 60. The reason why this happens is because the angles add up to 90, another thing you learned in geometry that you probably don't remember. And that's okay for right now. For right now, for today, I just need you to be able to identify which side is opposite adjacent hypotenuse and tell me the ratio. So here's where I want you to pause the video and try number 3 yourself. I've already labeled the angle for you, so go ahead and try it. Okay, so I'm hoping that you paused and tried this yourself. If you did it correctly, you would have labeled this as opposite, adjacent, and hypotenuse. The sine would be the opposite over the hypotenuse. That would be 1 over the square root of 2. The cosine would be the adjacent over the hypotenuse, which would be 1 over the square root of 2. And the tangent would be opposite over adjacent, which would be this 1 over 1, which just becomes 1. These values on this page are what are known as like the special trig values, right? When you move on to, pre-calculus or even calculus 1 in college, right? These values you're going to have to know off the top of your head. You have to memorize them. For this class, for Algebra 2, we just want to notice relationships and be able to identify the ratios from a triangle. All right, so this next page kind of takes us from geometry into Algebra 2. Number 4 is a straight up geometry question. I could teach a geometry class and throw that onto one of my lessons. But we're going to use it to kind of see what we can do here. So here's my triangle. I don't know all three sides of my triangle, which is a problem for us, but we know that there's something we can do when we have a missing side of a right triangle. It's one of our good friends from algebra and geometry, Pythagorean theorem. Remembering that a squared plus b squared equals c squared, c has to be the hypotenuse. So since I don't know this missing side, I'm going to make that a. So we'll say a squared plus 5 squared equals 13 squared. It doesn't matter if my missing side is a or b, I'm just going to throw a there. So if we do some quick math, which you should be able to do already, and we do some subtraction, and we do some square rooting, we can see that this missing side is actually 12. So if I want to find the sine of theta, that would be the opposite side to theta, which should be 5, over the hypotenuse of theta, which would be 13. The cosine of theta would wind up becoming the adjacent side, so 12, over the hypotenuse side of 13. And the tangent of theta would be the opposite 5 over the adjacent 12. So it's really just us doing some quick Pythagorean theorem, identifying which side's which, and knowing the ratios. Now, like I said, number 4 is a geometry question. What makes a question a algebra 2 question? Number 5 says, consider a right triangle whose acute angle is theta. This is important, not necessarily for today, but in the future. This means that it's between 0 and 90. And it says such that sine of theta is equal to 7 over 9. So they're telling us we have a right triangle. I need to draw one. Now, you technically could draw this triangle however you want, but we're going to draw it specifically in a way for a reason for algebra 2. I am actually going to make an x and a y axis and exaggerate quadrant 1. And in quadrant 1, I'm going to draw a right triangle. For today, just draw it that way. You'll see why tomorrow we're doing it. And I'm going to put theta down here by the origin. Every triangle for today's lesson that we're going to draw is going to look like this unless it's given to us. So if I know the sine, I know the opposite side to theta, and I know the hypotenuse because it's a ratio. Just like the previous problem, I don't know the missing side. So I'm going to say a squared plus 7 squared equals 9 squared. And I'm going to just keep doing my algebra until I get something that makes sense to me. So I have a squared is equal to 81 minus 49, which is 32, meaning we have the square root of 32. However, we can simplify that. There's a perfect square that goes into 32. The perfect square that goes into 32 is 16. So A is really 4 square roots of 2. This missing side is 4 square roots of 2. Now, because of that, I can find the cosine value. Cosine, remember, is adjacent, which is that side we just found, over the hypotenuse. I can find the tangent value, which is the opposite side 7, over the adjacent side, which we just found. Number 6 says to let P be the point 6, 8. 6, 8 is in quadrant 1. So just like I did before, because I just said we're going to make all of these the same, I am going to draw quadrant 1 exaggerated. I'm going to draw a triangle in quadrant 1. And I'm going to put point P floating up there at the coordinate 6, 8. If I know that coordinate, I know two sides of this right triangle. I know the horizontal side and I know the vertical side. Because I would count 6 boxes to the right, 8 boxes up, to get to that location. I don't know the hypotenuse, so I would use, again, Pythagorean theorem, but this time I'm going to make c the unknown value, do some quick math, and you can see that c is actually 10. So if I want to find the sine of this angle, well, that would be the opposite side over the hypotenuse. The cosine of this angle would be the adjacent side over the hypotenuse, and the tangent would be the opposite side over the adjacent side. You really want to go through and simplify the fractions? You don't have to. I just care that you know the ratio. At this point, I'd like you to pause the video and try number 7. So again, for this video, if you were pausing it and coming back, I'm hoping that you drew a picture similar to this one. The big thing here is it does tell us that B is the right angle. So make that your right angle. If you do some squaring here, you're going to get 20 is equal to c squared, square root, and you get c is equal to the square root of 20, which we can break down to 4 times 5, meaning that that missing side is 2 square roots of 5. Now, I want to know the sine, cosine, and tangent of angle A. So angle A is here. That's kind of like my theta. So this is my opposite. This is my adjacent. And this is my hypotenuse. So we could say the sine of angle A, well, we use theta here. It's telling us it's called angle A, is the opposite side over the hypotenuse. Again, don't worry about simplifying. I just care that you know the ratio. The cosine of A is the adjacent over the hypotenuse, and the tangent of A is equal to the opposite over the adjacent. That's all you have to be able to do for these problems. If you want to reduce it, you can. It's totally up to you. I hope this made sense. I hope you got a lot of information from this. The next thing that I'm going to ask you to do is to try these practice problems. There will be a separate video posted for you to try these practice problems and go over your answers. But please try them first. Don't just go right to the video. And I'll see you soon.